Hello, my name is Kenan Nebi, and this is my MAE 494 energy efficiency project on EV energy consumption. Here, we're going to be looking at the feasibility for using solar energy to improve EV energy efficiency. These are my group members who I'm collaborating with on this project, and we are Team Lightyear. Let's first look at using solar technology to improve energy efficiency. Here we have a relatively high efficiency solar panel known as the triple junction panel at 37% efficiency. However, this is a complex system made from expensive materials, and panels like this have long payback periods, which discourage manufacturers from ever using them. Solar technology not only is expensive, it comes with hardware limitations. Curved surface areas of EVs make it hard to create uniform illumination. Any sort of shading can reduce power output from panels, and the accumulation of dust or low-angle sunlight can drop panel efficiency much further. The overall cost and hardware limitations prevent this from being applied today. Now I'll shift focus to the cooling of the EV battery, which requires lots of energy to maintain during vehicle operation. Currently, the most common method used is liquid cooling. These add lots of mass and can also reduce overall driving ranges. So creating a compact yet long-lasting cooling system is proving to be one of the biggest challenges in EV manufacturing. How can we find ways for solar to improve this? Here, we have previous research on solar panels directly improving energy efficiency of EVs. First, we have longer driving ranges to perhaps offset the extra weight we added from the battery cooling systems. Second, AI-driven maximum power point tracking, which is a technique used to ensure systems extract the maximum power possible from an energy source. And last, the use of solar can also reduce the HVAC load on a vehicle by roughly 15%. Here we have more research on the advances in how EV manufacturers approach thermal management of batteries and improve their cooling systems. As you can see, most of the research is into the advancement of better cooling systems. Little has been done in terms of using solar technology, however, to improve battery systems. All we can say for certain at this point is that panels may reduce the demand load from a battery. So now let's take a look at prior intellectual property and commercialization on improving the energy efficiency of EVs, the most well-known being Tesla Motors, who are looking to improve the liquid cooling of the battery, trying to achieve uniform temperature distribution across battery modules. Another company, LG Chem, is looking to use phase change material, integrating it with their battery tray to maintain stable temperature. As you can see, most of the focus is on the cooling of the battery. Like we said before, this is the most inefficient part of the EV, so it's perfectly understandable. Looking now at the commercial use of solar roof integration, we have models such as the Toyota Prius Prime, which you may heard of before, Lightyear Zero from the Netherlands, featuring a standard panel to improve driving range. We have the Sono Motor Scion, who uses solar body panels to primarily reduce HVAC demand. I also thought it was interesting that they said battery trickle charging can occur. These are our references and links to previous research if you have any more time to look into those as well. These are our patents for all the devices we mentioned and the companies who are doing research into battery cooling. Thank you for your time and patience.